Alright, have you ever had a voltage regulator laying around and you're like, boy, if it was just the right voltage, right? Just the right voltage. Your son's or daughter's favorite toy broke down and needs a voltage regulator, and you need a 3 volt, but you can only find a 5 volt. It's annoying, right? Taking case, this one's really nice because it has a slider. Ooh. Of course, these are not always readily available. And sometimes they're just inaccurate. Like I need maybe a 5 volt, but look at, there's only a 6 volt and a 4.5 volt. No 5 volt there. 6 volt, 4.5, no 5. Ugh. So, first off, remember that there are milliamps. Okay, so you should not tend to stray away from your milliamps too much. But other than that, voltage can be adjusted pretty easy with the right survival tools. So I'm going to use a scenario. I found a 3 volt laying around, but I need a 1.5 volt. What do I do? Well, first off, always think ahead. This is a veritable version of a voltage regulator. It is a Ep1S1, and you can purchase this at Radio Shack for like $3. Keep this on hand, it's very handy. Okay, breadboard. The way to get power to your breadboard, this can change. Basically what I did is I took one of these. The rubber band kind of keeps it at an angle because it's just the right angle to, well, this is kind of wore out, so that's why the rubber band's there. Not to make excuses. And then it plugs into a terminal, and then that powers my breadboard via these 2 holes. Okay? Okay, what I need to do is find what resistance will equal 1.5 volts. Okay, so I'm plugging that in about right there. Then I'm going to try to put these in real time. This takes a lot of freaking dexterity. The first pin on your voltage regulator is your input. I need a good ground. So I'm going to go from the ground to the ground. I'm going to ground it from the terminal to this bar. This bar runs all the way across, and everything I touch in this is now ground on the blue strip. Okay, next I need an output. That's what this little wire is for. Notice it has a gator clip attached to it. Notice the gator clip is crimped on one end. Why? Because that way I can put my multimeter in it. So my positive of the multimeter is attached there. So you need a multimeter, by the way. Ooh. It's set to DC volts. It doesn't have to be a very expensive one. It just has to read ohms and volts. Okay, next I have to get a way of gauging the negative. So the same sort of dealio is mounted there, and again my multimeter is plugged into it. Bam bam. Caps. Caps take in energy, store energy, and release energy. So we want a constant stream of energy, therefore we need caps. This is a 1 UF, and this is a 0.1 UF. Now, the 1UF is a cap that has a positive and negative, so actually the longest one is positive and the shortest one is negative. The other one has no positive and negative. So if this is negative, the shortest one would go into the little bar. This is going to go onto the third pin of your voltage regulator and then right into ground. And then I'm going to cap the other side too. So on the first pin of the voltage regulator to ground. Alright, now you can get a potentiometer anywhere at Radio Shack. I got this really small one I like using, but certainly you can use bigger ones if you wanted to. If it's a bigger one, I just solder 3 leads down into it so it fits in a breadboard. I like the really small one for this video. I think this is a 10K, not sure, doesn't really matter though. Okay, so there's 3 legs on this, and from my left to my right I'm going to name this one pin 1, pin 2, and pin 3. I'm only going to be using pin 1 and 2. Okay, now this one's a little bit trickier. So the ground from pin 2 of the potentiometer needs to go to the ground there. So move that cap out of the way because I hate that when people that do the breadboard thing on YouTube don't move their parts around. Okay, this one goes to the middle leg of the regulator, to the first pin of the potentiometer. Once you get this circuit built, you can get it looking a lot better, but for right now you need to build it this way in order to figure out what is the resistance to drop it from a certain voltage. Okay, again, so we're going to play the role of I found a 3-volt one. So this is on 3 volts, which is a weird power supply because 3 volts is actually 4 volts. Don't ask me, it's an RCA thing. Hence I like using this method to drop the voltage. So you can see right now it's reading 4.3 even though it's on 3. So that's kind of dangerous in my opinion. So what I'm going to do is turn this potentiometer down until it hits 1.5. That's what I really need. I need a 1.5. If you don't see any change, that means you have something not hooked up right. So I'm going to get my snout in here and see if there's anything that I missed. Oh, sure enough. This is going to go one more pin in. There we go. Sweet. Okay, there we go. So I need 1.5 volts. I'm just turning this potentiometer until I hit 1.5. There we go, 1.5. Sweet. Alright, now what I'm going to do is take this potentiometer off carefully, and I'm going to read the resistance between pin 1 and pin 2. Now you can use your gator clips. Connect one to pin 1, and the other one you can just touch with pin 2. Set your multimeter to ohms. Ohms. There is a formula for this, but I'm a DIYer. We don't believe in formulas. Okay, so right here it's going to say and I gotta make sure I'm touching only those. Sorry, this is really hard to do and watch what it looks like on video. So there we go. Gonna touch those two, and I got 486 ohms. 486 ohms. Alright, so is there a 486 ohm resistor? Well, if you look up color chart resistor online, 480 ohms, the closest thing you got is 510 ohms. Okay, for 510 ohms is green, brown, red. Green, brown, red. Then you can get these little stripes on there. See the little stripes? Yeah, so it would have to go green, brown, red. I don't know if I have a green, brown, red, but I'll show you what happens when you find a green, brown, red. What you do is now you can replace the potentiometer with the red or green, brown, red resistor located here. Just like that. And then you have now changed the energy or the voltage coming out of there, and here's your negative and positive. Again, very ugly as a circuit coming out of a breadboard, but if you were to mount this via somewhere else or somehow else, maybe something like circuit board, it looks a lot better. Okay, and it's not too bad to have this mounted all the time, but the problem is, you know, you might potentially bump this, and then when you bump it, it's going to bump up the voltage really bad. So always gauge it with one of these and then replace it with a resistor. Alright, so that is building a custom power supply. Enjoy. One disclaimer I want to make before I end is the fact that this right here, this voltage regulator, if it gets too much of a difference in voltage, let's say you take 12 volts and you're trying to reduce it down to 1.5 volts, well, it heats up. So in that case you need a heat sink for it. If you just drop voltage just from like 3 to 1.5 or 12 to 9, there's not a lot of voltage change there, and therefore it doesn't have any heat. But if you are, and this will go up to 36 volts, right? So if you take 36 volts and drop it to 1.5, you could imagine the heat coming off this, you would have to mount it to a small block of aluminum or some kind of heat dissipating metal. Alright, so that's just a disclaimer I wanted to put out there in case you get nuts and try to voltage regulate it to death. Enjoy.